Hello, my name is Jordan Deyton, and I am a Postmaster Research Associate at the Oak Ridge National Lab and a developer for the NiCE Integrated Computational Environment. Today, I'm going to demonstrate support for CASTLE's VERA simulation code from within NiCE. First, I will give you a very brief introduction to NiCE. For VERA, I will show you how to set up input and then how to launch your job. So, what is NiCE? NiCE is a cross-platform, 100% open source workflow and data management application. When formulating the idea of NiCE, we realized that there is a standard model of scientific computing. All computational scientists, from the newest user to the most skilled researcher, have a general workflow that involves developing simulation input, launching the code, analyzing output, and archiving the data. NiCE offers a standardized, simple interface to each of these tasks and reduces the time and effort needed to, for instance, write scripts for generating input or learning how to queue jobs for a particular computing platform. In this video, I will demonstrate the first two steps, code input and job launching, for VERA, CASTLE's light water reactor neutronics code from within NiCE. Before we can actually run VERA, we first must generate some input. Once you have opened NiCE, you will be presented with this screen. Since we do not need the transformation view, the first thing I will do is to minimize it. Now we need to create our input. In NiCE, we have what we call items for individual tasks that we support. To create an item for VERA input, we have three options. We can click the green plus button in the item viewer on the left. We have a shortcut button on the toolbar for creating an item, and we can also create an item through the File menu. Once the item selector window appears, we are presented with a list of items or tasks that you can use in NiCE. For model input, we have model builders, for launching jobs, we have launchers, and for analysis, we have analyzers. We also have a handful of other items for other codes, but for our purposes, we need to create a VERA CS input. So, select the VERA CS Neutronics Model Builder and click OK. Notice that after creating a VERA input item, NiCE presents you with two views. On the right, you have your items editor, which allows you to tweak or modify your VERA input. On the left, NiCE switched from the item viewer to the tree view that shows the case ID parameters. In NiCE, each item has a set of tools at its disposal, so that when you create the item, NiCE will show you everything you need for that particular item. In this case, the tree view allows you to browse the parameters of the CASTLE problem template that is currently specified. Back in the input builder's editor on the right, you'll notice that we have a list of templates available. In order to have these templates for your use in NiCE, you need to place them into a specific location in your user folder. However, we cannot currently make these particular data files publicly available, so please contact one of us for access to these or similar files. If we need to switch to Problem 4, we simply select Problem 4's XML template and hit Save. In the tree view on the left, we can browse and modify the parameters for Problem 4. For instance, we can modify materials in individual assemblies. Again, let's go back to the editor on the right. Once we are satisfied with our input for VERA, we need to write a file specifying our input model. In the top right, next to Process, select Write CASTLE Parameter List File and click Go. NiCE gives you feedback as the file is created, and if any information about the input needs to be shown live, it will appear in the console view. You may have been wondering why there is so much empty space in the VERA Model Builder. This is where NiCE is flexible for simulation code developers. Depending upon the requirements or requests of developers and users, we can make certain options available here to further modify the input. For instance, look at this NiCE item for another simulation code's input. Here, we have a number of input features that users can change before running the simulation. Built on top of the Eclipse platform, NiCE can support a wide variety of controls for manipulating model input. The next step is to run the simulation based on the input we just generated through the VERA CS Neutronics Model Builder. First, we need to create a new item, in this case, a VERA CS Neutronics launcher. In the new editor that appears to the right, you configure a job to run on a computing platform. The first step is to select the input file generated in the previous section. You can identify the file by the name of the model builder, and if you don't know the name of the model builder, you can view its name by either navigating to its editor by clicking on its tab, or you can look at the item viewer on the left. In our case, the input file is called VERA CS Neutronics Model Builder _1.xml. The next step is to select the computing platform that should run the simulation. Here, we have 3 remote servers that are capable of running VERA. Lastly, we need to run the job on the remote platform. To do this, to the top right next to Process, select Launch the job and click Go. NiCE will prompt you for credentials, and standard output and standard error will both be fed through the console as the job runs. Once the job is completed, you will have your output files from the simulation. With VERA, you also get NiCE ready data files stored in the HDF5 or .h5 format. At this point, you can open up a reactor analyzer and take a closer look at the output data. However, if you would like a more in-depth view of the analysis phase, please see our video on the reactor analyzer. In conclusion, to run a VERA simulation, you must create a VERA CS Neutronics model builder, load a Castle challenge problem template, tweak your input, and generate a Castle parameter list input file. Then, you need to create a VERA CS Neutronics launcher, select the input file created by the previous step, select the computing platform, launch the job, and wait. We hope this video has been helpful for you, and we very much appreciate any feedback you may have. If you have any questions or comments, feel free to visit our website or contact us through email. Please check out the other videos on our channel and feel free to subscribe. Thank you for watching and have a fantastic day.